Very good morning. In this session, we are going to discuss how to check whether a given number is prime or not using two approaches. One is recursion, second is non-recursion. Non-recursion is a normal one, and I will explain you how to develop a recursive algorithm from non-recursive algorithm. We take an integer n as a command line argument. Let it be 15. 15 is not prime, so answer will be false. This 15 is taken as args0, which is an integer, which is a string, should be converted to or should be passed to int. Right? So this is input for our program. Now, let us call a method which is non-recursive method. Method name is prime. Input is n. And let us also write a recursive algorithm output is recursive result. The name of function is prime r. So we have two inputs. That input for the first method is n1. Input for second method is n2. And this is n1. Let us read one more command line argument. Instead of typing, I just copy and paste to save your time. This is n2 and this is args1. Enter the values here. First one is 15. Corresponding output is false. Second one is 17. So corresponding output is true, right? Now let us write the functions. The first one, public method, static method, returns boolean, name is prime, takes n as input. Now, second method, signature is similar to first one. Its name is prime r. Let us complete the first one. This was discussed many times. Say if n is less than 2, I mean n is 1, return false. Right? Start with I equal to 2. While your I is less than or equal to n by 2, but you can go for advanced or more optimum condition, the square root of n. You need not go up to n by 2. Square root of n is enough. If our n is divisible by I, then you can return false. If n is not divisible by I, then check with next I. Check with next I. After checking with all possible I values, if you could not return false, you will be returning true. Right? Now this is non-recursive one. Let us check the result. Input is 15. So it should be false. Here I is replaced by 2, not identically equal to. Run it. Missing return statement. Let us remove it. False. Let me make it 11. Then it is true. Okay. Now let us write recursive algorithm or recursive method. First condition can be taken as it is. If n less than 2, return 1. Okay. Now here, if n is divisible by I, return 0. Sorry, if n is divisible by I, that is n mod I equal to 0, you return false. Okay. Otherwise, to solve the problem, with next try. It is like passing baton to next one, in the relay. So what is the next part of problem? You tried with I. N is not divisible by I. Then you try with I plus 1. Okay. So you need one more input here. Let it be I. And what is the initial value of I? Initial value of I is 2. Okay. Initial value of I is 2. N mod 2 is equal to 0. Then n is not prime. Otherwise, you solve the same problem with next type. How long you check what is the maximum value of I? There should be a limit, right? That limit is if n is greater than, take this condition. If n is greater than this value, then stop and return true. Because you could not return false. So go to the maximum value of I. Okay. If you do not put this condition, it will end up in infinite loop because I will grow infinitely. So there should be some terminating criterion. This is that. Okay. Now let us check. What is second input? 17. 17 is prime. So expected output is true. Semicolon is missing here. This is prime R. Otherwise, we end up calling previous method. If n less than 2, you will be returning false. Don't return integer, the Boolean function. Right? So for 11, input to non-recursive, answer is true. For 17, which is input to recursive, is true. Let us make it 10. The second one is false. Okay. So I hope you understand it. First, you try with initial value. Okay. And then you try with next value. How long you will go? You will go up to this. Or if you want to simplify it, you don't want to have advanced criteria, you can make it I greater than n by 2. Okay. And here I less than or equal to n by 2. The popular condition. Doesn't make any difference for small values of I. But higher values of I, it does make a difference. For 11, it is true. Recursive output. Sorry, non-recursive output. For 10, it is false. I hope you understand it. Only thing you need to remember is to supply next input and there must be a terminating criterion. Otherwise, it will go up to infinite level. Okay. So I hope you understand it. Thanks for watching.